All right, so our second example, same thing, we're just practicing this rational root theorem. First step, set it equal to 0. So I'm going to subtract the 64x and add the 64. Also, what I'm going to do at the same time is I notice all 5 of my terms have a common factor of 2. And when your GCF is numeric only, you can divide every term. If your GCF is a variable, you cannot divide by a variable because there's a potential that the variable is 0 and division by 0 is undefined. So as long as your GCF is a number, go ahead and divide it out. So I'm going to do that at the same time I set it equal to 0, dividing each term by 2 and subtracting my other 2 terms over as I divide them by 2. What this does is when I use the rational root theorem now, I am going to have fewer numbers and smaller numbers to work with for my guess and check. And fewer numbers when you are guessing and checking is always better. All right, so we're going to use our rational root theorem. Our lead coefficient is 1, which, just like our first example, means that we only have to look at the factors of the constant. So we're going to list all of the factors of 32. Oops. Thinking too hard there. Okay, so those are all the factors of 32. So I'm going to set up my synthetic division now to check and see if any of them are indeed factors. Now what I notice on this one is I'm not actually going to start with 1 because my final answer is 32. And multiplying by 1, even if I'm adding it to some numbers, probably not going to get me up to 32. So I'm going to go ahead and start with 4 and see what happens. Obviously 32 plus 64 is not going to get me to 0. So I'm going to cut my number in half because I'm seeing that the 64 is twice as big as 32. I'm also noticing that it's the wrong sign. So I'm thinking maybe I'll try a -2. Sorry, that's an 80, -80. When I multiply that by -2, something happened. This is way not what I was expecting. I thought cutting it in half and making it negative would make those numbers work for me. I'm still thinking it needs to be smaller than 4. Maybe I try a +2. I can't extend my page unless I move that. I multiplied that by, I was wondering, I was like, I thought I got this to work when I tried it earlier. So, let's try the +16. And we got that to factor. We've got that remainder of 0, so we know that x minus 2 is a factor of our original equation. And then these, it was originally to the 4th power, so we start with x cubed. And then see if we can't keep factoring. Now this is a cubic function. It's looking to me like it will factor by grouping, but once we get into class, remind me to show you this app and it'll give you the zeros right away so you won't have to do the factoring by grouping. So this one, if I factored it really quick, I'm thinking we get x squared plus 2, leaving us with x minus 2. When you factor by grouping, I'm trying to save us a little bit of time on the video. So then we set each piece equal to 0, and actually what I'm going to do first is I notice I have 2 factors. I forgot to mention this on the first example because the multiplicity for each of the roots was 1, but here I've got the x minus 2 squared. So this root, this x minus 2, when I set that equal to 0 and solve, has a multiplicity of 2 because of that power. The x squared plus 2, Setting that equal to 0, subtracting 2 from both sides, and taking the square root, we'll get plus or minus I times the square root of 2, and those will each have a multiplicity of 1.